Astronomers using NASA's Hubble Space Telescope have found a rare, ultramassive white dwarf formed from merging stars. The discovery was made possible by Hubble's sensitive ultraviolet observations and suggests these unusual white dwarfs may be more common than once thought. The white dwarf is 128 light-years away and 20% more massive than the Sun. In visible light, it looked like a typical white dwarf, but Hubble's ultraviolet data revealed something unusual, evidence of carbon in its atmosphere. A white dwarf is what stars like the Sun become after they exhaust their nuclear fuel. Near the end of its life, this type of star expels most of its outer material, creating a planetary nebula. Only the hot core of the star remains. White dwarfs that form from a single star usually have atmospheres made of hydrogen and helium. These thick layers cover its carbon and oxygen, or oxygen and neon surface, preventing their detection in the star's spectrum. When carbon shows up in a white dwarf spectrum, it can point to a more violent origin, such as a collision between two white dwarfs or between a white dwarf and a subgiant star. These collisions can burn off most of the hydrogen and helium, leaving only a thin layer behind, allowing astronomers to detect carbon on the white dwarf's surface. This white dwarf's merger origin would be impossible to identify without Hubble's ultraviolet sensitivity. In hotter white dwarfs, spectral lines from elements heavier than helium fade in visible light and stay bright in ultraviolet, where Hubble can detect them. Researchers discovered this white dwarf's unusual origin by looking at its ultraviolet spectrum, suggesting that other white dwarfs with a typical visible light spectrum may also be the result of cosmic collisions. The team plans to explore this possibility further and hopes to continue this research by studying how common carbon stars are among similar white dwarfs, and how many stellar mergers might be hiding among the normal white dwarf family. This research will help improve our understanding of the environments in which stars evolve and the paths that lead to supernova explosions.